Okay. T. Yeah, this is a difficult problem. I don't know what this S is doing, but you can't pipe the output. It's really strange. There is no readme. Well, S stands for source code, so yeah, the readme is not part of that. Let's do this. Name readme something. Although I'm going to use it in cairowindow right now, it's more of a machine learning thing, isn't it? So let's start searching from there. Okay, yeah, and source. Okay, the more general case, I think, is where we have a vector. Well, yeah, general means difficult. So now I have a vector, and then in machine learning, it's like the weights vector, but I guess that doesn't really matter. So I'll call it W anyway. How did I denote vectors? If I did, I think I did. W, capital W. It's a bit boring, but okay. Yeah. Fuck this. Could just give it to me, damn it. Instead of just a description. But doesn't really look like what I'm searching for, though. What was the other one called? Nothing. No. What is shit, sorry. Yeah, maybe this is the one, but it doesn't look like the correct symbol. The microphone turned away. Hmm. Okay, fuck this. Yep. Yeah, so why didn't you give it? Ah, stupid AI. So, no, I'm confused. Is this the right thing here? I guess so. Anyway, let's begin with a super simple example, and that means one dimension, right? Yeah, well. It's not even worth it. Oh, I have it here as well. Gradient. That is the same card. Yeah. Now, yeah, I mean, it must have a minimum, so it can't be a linear function. So the simplest is a squared. Oh, there we go again. I really want to have these things on my keyboard, you know. It's pretty tiresome that continuously have to search for them more or less in existing. No. By accident I find it. So x squared plus bx plus c. You see, there's the problem. I think that what I actually calculate is the derivative relative to w of f. That's not the right thing then, is it? Is it on the derivative or the gradient of f with respect to w? I mean, I think that's how I did it here. Yeah. So here the L is a loss function. Maybe I should call the thing also L. I just copy as much as possible from this. What's in a name? Does anyone see a round E here? Yeah, there it is. Okay, so Now I want to have so we take steps. So we start with some starting value for w, and we calculate the next value, and then the next, and the next, and the next, and then we hope that we zoom in on the final value. And I was thinking I could do that by indexing w, but in the end we need indexes for w as which dimension it is. So if you have multiple dimensions, it's just going to be w0, w1, w2, and so on. Rotation is a problem already. Yeah, maybe double indexes. I don't know. We'll just start with an index, I think. Gradients. Surely I have some kind of divergence thingy somewhere. No, building not. Oh well, I just wrote it on one line. Minus b divided by 2a. What is that? That's b squared. A, that is A, that looked like C, but let's make sure. B squared. A times minus b squared divided by the square of that, so divided by 4a squared. Minus b squared divided by 2a. It's totally not C. So the 1a here drops out. And this is half as large as that one, so we get minus the first. In other words, we get C minus that. C minus b squared divided by 4a. Okay, now in order to calculate the minimum, we need to know B and A. We don't really care about C, apparently. So there's absolutely no way that this can work. We need another value with a C. Otherwise, I can't get rid of the C. My first question is now, what is a sensible value to pick for W1? Basically nothing. I mean, it's just completely arbitrary. Completely arbitrary. I would say you want to change W only a little bit so that at the very least, it makes sense that you are calculating the second derivative like that of the point that you're in. But yeah, on the other hand, if it changes w only a very little bit, very little, then you might immediately run into floating point roundoff errors. I'm listening to horrible music as usual. I mean, I'm thinking, my feeling is that there's absolutely nothing you can say about it, what the next value should be. And not even in the simplest case of one dimension and assumption of the simplest quadratic loss function that you can imagine. Now, I understand that normally people, I mean, in the machine learning thingy, let's well look for an alpha here. It was, well, let's look for W. I thought I already saw. I need something like, yeah, there it is. So this is the normal, well, the simplest formula that people use. You just have some constant or whatever it is. Thing must have a name. Doesn't say it here. And you subtract some constant times the calculated gradient from the weights, and then you get the next weights, the new weights. Oh yeah, the learning rate. Yeah, well, here it claims that you should not take a value that is too large, but on the other hand, if you take it minuscule, and it turns out to be a factor a million too small, then yeah, I think it's pure random. So I'm gonna go for pick an alpha, but I don't know what alpha. I have no idea. So keep it to learning rate alpha. Next value, next attempt. What is a good word here? Just the next W. Next value, I'll say, and I'll give it a name. So that would be blip, subscript 1. Yeah, mine, this is, I mean, I have a lowercase w here, so it's one-dimensional to begin with. So I'm not sure I should use an uppercase here for the vector. Let's just write it the way it is. Namely, I'll keep using the roundy, although since we have only one, it's a partial derivative. But there is only one w, not a w0 and wi, etc. That's why the partial derivative is the same as the normal derivative. But I'll keep the notation with the roundy here. I don't know why, but it just feels... Maybe, yeah, I don't know. Or maybe not. I mean, they're the same, so I can pick what I want, I guess. Right, so then I get new values. Okay, let's fill this in a little bit further. Alpha times, and that thing was actually this. At W0. And I have to subtract that, so that's also a minus. So this one, plus W1 again. I believe that this should already be enough to immediately find the minimum. Because, well, if you assume that it's the loss function here is a quadratic function. So the first thing, of course, is to now we can get rid of the c. And then we should have at least two equations to solve for a and b. And then we have the minimum value. So yeah. Let's see how that works out. But the alpha must drop out as well. But yeah, well, anyway, somehow it must be solvable. Let me see how I want to do that. Let's work this one out. So just do that immediately. No. This is still the initial value, and now we're going to work it out. So this one is I need an A times, there's alpha is totally in the way here. Let's just do brute force. I'm going to subtract that. These two are values that we know. No, this is just a constant. Can this be simplified or not? That squared plus b squared minus 2 times b times the first thing. Yep. And then this one is yeah, it's like almost the same thing. Plus b times this times w0 minus b squared. And then the rest, which is equal to Yeah, I guess there's only half of that drops out. This drops completely out. And then I have a minus BW. Maybe you should let's multiply out this as well. I'm tempted to use my new symbolic toy to fill this in. See if it simplifies. But I'm afraid that if I do this manually, it's probably just as fast. Oh boy, yeah, we do this squared, then we get 1 plus 2 alpha squared times a squared minus 4 alpha a whole times w2 squared, which you then might as well multiply out as well. It's not correct. Yeah, we've got to square this one. And here we have minus 2b w0 plus 4 there. It's a plus 4b alpha a w0. Yeah, that's a b squared dropout. Plus b minus 2b alpha a w0. My God. Shall I use, I think I'm going to use my symbolic thingy, because the chance that I make a mistake starts increasing, and I still don't see how this simplifies. Or how to get where we want anyway, at all. I need to solve for that. If I put it into my symbolic stuff, I just type it in. I type that in, and then we ask for this, and then we see what comes out. I think Octave does the same thing, but at this point I know better how to work with my own code than with Octave, I'm afraid. Jesus Christ, I had not expected this to be this hard for the very simplest case. I must be doing something wrong. Come on. LW1. Nope. Tup, tup, tup. Yeah, of course. I'm a complete idiot. So we all knew that I'm a complete idiot, but in this case it's really bad. You don't need this at all. Wow. Let's use a different notation here. And this just makes things needless complicated, so I'm just going to use the normal formulas here, but then with the subscript 1 for, of course now we fill in W1. The idea that I just had while doodling on my paper here is that the first derivative is linear. And I just want to find where that is 0. Hello. So we have this value, and that's enough to find where this function, which is a linear function, is 0. Yeah. Let's not go too fast. Yeah, damn it, man! It already says it here. I just need to. Oh my god! Yeah, so I can completely ignore these. Completely ignore these. I can just use that one and that one. And that would have been a faster attempt, because I started with the top ones. I don't know what to do with this sentence, but in the end I want to get rid now of the b and just solve a and then b. That is 2 equations and 2 variables already. Okay, so this is L dash, what is it, accent, W0. And here I have that value. And this is W0, and this is W1, and this is WM. Okay, well. It can never be. It's always too steep, this thing. I don't want to go higher than this. Okay, maybe one more. Plus. No, let's put another plus here. Which is then that point. I can't draw the parabola, but the parabola obviously is horizontal here. This is the first derivative of the parabola. So the parabola is something like, I don't know, anything which is horizontal here. And now we have a parabola. And then this height here now is how steep it is. So this value here is... sorry, this value. And from that we can conclude that Wm is something, but really we have L equals some steepness factor. A, B, C, D, E, F. Oh, I'm gonna use a Greek. Something Greek. Beta, probably. Greek beta. Looks very weird, dude. Give me a normal beta. This one. Small, okay. Yeah, which is 0 at W equals Wm, the M for minimum. So this difference divided by this difference. That's the steepness factor. And I can apply that again on this point, I guess, to find Wm. aka on that one. I don't want to start with W1. Why would that not be possible? Yeah, this is correct, isn't it? Yeah, this is correct. So move the Wm to this side, you get W1 minus Wm, and then this thing to the other side is plus L accent W1 divided by beta. So if you move the beta to that side, you have the same formula. That's the answer then. Which is a very well-known formula, because well, it's just the same as this one. If you want to have the next value, I mean, if you set alpha here to beta, then yeah, then you would that just exactly one more step and you're done. What? I lost it. I don't know what I did. Okay, now imagine we continue anyway. What would happen then? I think it doesn't really matter what alpha is, because the next step would be W3 is equal to W2, which is Wm, minus alpha times the derivative at Wm, which is 0. So we just get W3 equals Wm, and so on. Just it gets stuck on Wm. I'm thinking about if I want to swap these two and these two as well. Mathematically exactly the same, of course, but maybe go from W0 to W1. So it kind of would be more logical to talk about the difference in those two W values as a value that you have to add to W0 to get W1, which is W1 minus W0. I'm going to do that immediately here. And then to avoid confusion, maybe I should even have that here as well already, which means that I should subtract that one from the other one. W0. Yeah, this is 1 over beta. So that swapped, aka this thing. Oops. Right, now. So that was the simplest of the simplest case. I'm tempted to think about instabilities. Stabilities if this is not the case, if it's not a quadratic, but let's say, I don't know, I guess the next step is then an third degree polynomial. Is it possible to be too enthusiastic then by doing this? Yes, this third degree doesn't have a minimum. Would have to be a fourth degree then. Which kind of seem unlikely, I have to admit. I think this is of high practical value. But maybe we want to find a local minimum. Well, we don't, but I don't know. What if there is one minimum, but that minimum looks locally like a third degree? That could be possible. Or is it? Well, yes, of course. I mean, let's say the third degree polynomial would be something like this, and then we have a minimum here. Then if you zoom in on this minimum, it looks like a third degree because it's exactly what it is. And then if you go further that way, we don't have to go down. We can do something else. Who cares? But then locally, it's still a third degree. And then what happens if we treat that local minimum of the third degree polynomial as if it is a parabola? Do I still find then the minimum very quickly or not? Is the question. Suppose that what you need in that case is some kind of a binary search-ish thing. You try to find 0, but what if you overshoot? I think that if we overshoot, that's quite obvious. Apart from having a real local minima. I mean, if it just, not a parabola, but something more weird, but it's still, I don't want to make a local minima, but something like, and then here's a minimum, and then we go, there's really one minimum, but the derivative is doing all kinds of things except going up. We don't have a local minimum. Then I think that what will happen is that either you don't go fast enough. So for example, it's flat here and then it goes down and there's a minimum. Then if you look at this part here, it looks like maybe a parabola like that. You also overshoot. It's really like flat. You think that the minimum is like here. Hell, it could even look like a convex thing, which if you treat that as a parabola, then there is no. Well, you would go the wrong way. Damn it! Really? No, you're searching for the zero of the derivative. So if it looks like this, and it goes steeper and steeper and steeper downwards, then this trick won't work, because then you say, oh, that's a parabola like this, and then the derivative is 0 here at the top. So then we go upwards, go the wrong way towards the top. This is detectable, I suppose. How would I detect that? That's a good question. I think you have to look at the difference then of these values. They have a certain sign. So we can calculate, I meant this one. So we can calculate this value and this value and subtract them, and then that has a certain sign. And then we also subtract the derivative value. And if the sign is not equal, then we would go the wrong way. We do this. But yeah, then it's like proven already that it's just not the minimum is not going to be a parabola. I mean, you see locally, you see a parabola, and you're here. You don't want to go to the top, which is flat. You want to go down. But if you assume that it's a parabola, well, we have to go down infinitely, which is also not what you want. So in that case, I think you have to continue in the same direction. But yeah, how fast? It's again absolutely unknown. Yeah, I think that investigating the one-dimensional case still is very interesting. The two-dimensional and 3, 4, 5-dimensional cases have their own problems. But why not search for an algorithm that works well for the one-dimensional case first? And then I can actually show it, you know, in a graph, what happens. Just draw some random function, loss function, we pick a starting point, and then we can exactly see what it does, searching for the minimum. So that would be kind of cool. Okay, so right, now how is that going to look then? Well, we begin with the loss function, I suppose. So Can I just copy that from something else? Oh, the tendency error. That's why it was there. Yeah, it's already included by the debug O-stream operators, of course. Well, anyway, we need obviously a window and a layer, and let's say, yeah, might as well copy these. Probably need thread. Hey, Poise Bunny. You're just spewing nonsense, Poise Bunny. How does this look great? I mean, you're being a cheerleader. But you say it looks great exactly at the moment that there's nothing that looks great. Let's define a function. Double. Yeah, the colors are pretty as usual. Double function L double W. Annoyingly, shall I just use symbolic to define this? Then I have the derivative immediately as well. Well, not for crazy functions, but for a lot of them. I bought French fries today. I still have some left. They are completely cold now. This is how I make symbols. So look here. Okay. I'm looking if this is safe to do this for global variable before we reach main. It's not, because this suffers from the static initialization order fiasco. If the database is not defined yet, then this would crash. I should probably just, come on. I could make it a static inside this function though. Maybe I should do that. Or I could make yeah, of course. I'm not even going to have I'm sorry. I shouldn't eat anyway. I'm not going to have a global function. Let's make a class for this. Yeah, I turned my mic away because I was eating something. Still eating something. Uh-oh. Yeah, I don't know. No, not necessary to make that static. Typical explicit private. Need to include symbol. Yeah, yes, Post Bunny. But I pronounce it as a double U. So I left one double out already. So that's why it's okay. Right. So I have a function class. I'm gonna create it here. call that L. That thing then creates a symbol from the symbolic stuff, and it defines, of course, the evaluation. Well, since this thing is called L, let's now call it an operator. No, I should call it a functor instead of a function. But it represents my function. I'll call it function. Okay, so I'm going to have some function, yes, and we return here the actual evaluation of that. Completely forgot how that works. I think I just call evaluation on it. So we have some function dot evaluate, right? Maybe I should make these constants actually, but it doesn't really matter that much. I can assign them. Derivatives not getting a color. It is alarming. Forgot how to do that. Surely I have a derivative somewhere here. Derivative is derivative. Did you just type it wrong? I might as well do a symbolic expression. No, I remember. No, I see how it was done. Expression, derivative, and function. So I wrote derivative wrong. Oh god, no, I'm stuck with that one. Derivative, I don't know what I wrote wrong, but what is the function here? Derivative. Derivate. I mean, I want to type derivative. I type derivate and I don't see that I type it wrong. That's sickening. Yeah, now I call that on. Maybe I should call them all like underscores. Oh, missing operators. Where do I have those defined? Yeah, I need to include symbolic.h, not a symbol. No, it got worse. Allocating an object abstract type. Okay, now I'm confused. I thought I could use a util square on a symbol, but apparently not. Do I have a square in symbolic? Not really, no. Can we do a square like that, really? Do have a square here. Wait a minute. Square. Square. Power.h. Yep. There is a square in symbolic itself. Makes sense, I guess. Either that or I can just do a square. Duh. But then I have to put parentheses around it because of this stupid precedence. Yeah, there I go again with the derivate. Right, so it says that the value at w equals 3 is 2.4 and the derivative of that point is 0.1. Well, I believe it because symbolic works, right? Right? So we have to test it. 2.4 on 0.1. Yeah. 2.4 is correct. Yeah, and the derivatives of 2 times a is 0.1 times w is 3 plus b, which is actually then a minus. Minus 0.5 is 0.1, so that is also correct. Now we want to draw this as a function. I still don't have function support, so I'm just going to make an array with a lot of values and then draw that as lines. I need a begin and an end value then. Let's see. The value should be enough. Well, let this run from, I don't know, test. Yeah, I'm afraid I have to determine the minimum and maximum value. Okay, let's see if this is correct. Suppose steps is 2. Then you have 0 and 1. And the first one, yeah, that's so it's correct. So last value is W max. Okay, now let's make a diagram. For a window with a plot, I mean. Where do we copy that from? I just gonna go for the last one, even don't care how big it is. Okay, the gradient descent thingy. Try. In space, scroll, okay, grid window, whatever. Background layer, probably. Second layer, probably. Open the window and start drawing. Okay, let's fix this one first. Let's do the try from here. I want to fix it at the end. It's part of the while loop. Let's just move that part. Let's add a standard string here that shows the formula. How do we do that? Well, L dot as a string or something. I think I can only write it to an O string, huh? Or not. Expression. Yep, can only go print on. Good, now we create a plot. Set X and Y range. I don't need printing, but it needs to be added to the background. Yeah, this is then W and this is L. That's what I'm going to print. And then X range means W min till W max. And L min till L max. No printing. Add the plot to the background layer. Then what is next? Color pool, all kinds of styles. No, line style I guess. Small line style. No points needed. Okay, now we start to seriously draw some stuff. And then in the end I have a loop here, which just draws more stuff. But it's in case I need a loop. And I do need a loop. Because I want to zoom in on... Well, I want to draw a point which gets closer and closer to the minimum. But for now, let's only draw the function. It's kind of a static thing then. So no loop required. Here I want to run over... Do I not already have some kind of support for drawing a function? Sure I do. Which early things did I make that to draw something? Circle Bezier. So it's already a Bezier. No, yeah, curve points. Great curve. That works with points. So making a vector of points and then call this. Now we have a curve. A slow curve, but hey, it's a curve. Curve line style. Okay, let's go lazy. Yeah, just black. Black is already the default. Might as well use that. We have second layer and curve points is then a vector of points, which I already filled, or already should have filled really. Okay, this is confusing. Pretty sure I made a vector with data points, which is suddenly nowhere to be found. Oh, it's here, before the try. Guess it should be inside a try, because the why not argument, as point is in the namespace, in this namespace. Okay, anyway. Yeah, okay, I'll just move it down in the inside here. Did not include plot apparently. That won't work. No. Insertion width is larger than 0 and height is larger than 0 or equal. Not a number. My range is not set. Oh, that's an empty range. Also, yeah, I'm doing something very stupid. Something. LSVI. Where is the thing? Gradient descent. It's like this whole loop is empty. If steps is zeros, and then I would understand why. We just get these values and they are the same. No, even W max was set to. Oh, if W max is set to equal to W min, then delta is not changing. And therefore W is not changing, so vel is not changing, though, yeah, that explains everything. The problem is W max, and I set it to -1. I want to shoot myself. Cool. The functions, you really, C plus, what? Why did I put a C first? I think it's determined by which symbol is what is it? Declared first or constructed first? Constructed first. Huh? At least that's what I thought. A single symbol. Surely these are done in this order. Surely they're done in that order, right? No, I don't care. Well, that's not very interesting. We don't even see the minimum. So, yeah, we clearly need a way larger value for W max. Let's try for no, still not very interesting. W is all the way down here. It's almost like it was trying to fill the hole and then was forced to not do that. But then still, you know, why is it not putting the W here? That is a bug. I think the reason that this happens is because I keep the ratio the same. So this is a distance of 1. And this is equal to this distance, which is 1. Yeah, I don't know. In this case, it's not an XY coordinate system thing, so the scaling doesn't really matter. Might as well turn the should probably plot. I'm gonna gamble that it is this thing. Let's say I'm gonna run for -2 till till 7. Destroy something. Okay. And then initial value could be put at 6.5 or something. Or here. -1.5. Let's pick -1.5. We're going to bed soon. No more exciting things happening. Just going to draw a non-draggable point. Create point here. The simple one. Yeah, create point. Need a point style for that. Let's copy that in a second then. Create a point. I don't know what point. Well, it's actually W. Nah, it's not W. It's like the initial. Like, I don't know. Jesus, how should we call this point? P. Point P. Create a point. Point style. And the XY coordinates are then W, comma, the value that belongs to W. W. Just calculate it. Lazy PC. Okay, I need a point style. Point style here. I'm so lazy, it's unbelievable. Color pool. Why not color index? Default is 0. I'm just going to set it to. I'm just not going to set it to it. Give me the first color. Okay, and then what? I want to have a label for this point. Draw a circle, draw a label. Oh, I don't have a label style. Okay, the initial value is here, and I don't like the color. Because it's the same color as this one. Let's try color index. Color index 1. Also not. What you could just specify it to be red. Is somehow not a good interface that I have to specify an integer. The reason is that you can have many data points in the plot and then just have them automatically given all different colors. It's nice if you have 30 colors, but if you just want one of them and you just want red, now I have to search for which one is red. This one is green. Could use it, but now I said I want red. It's clear that I want red. I could just look up my table and find out which one is red. But I hope, I'm still hoping that it is something pretty early in the table. Nope. Okay, let's find a color table. Color, what do you mean? Color, maybe? Color, let's see. Does this have a table? Totally has a table. Black background. I think we have a white background. Red, it would be it's like the last one. I don't have a bright red one. Nope. Isn't even the red one. Unbelievable. Yeah, okay, let's try this one. 83. And this is index 0, right? So minus 52. That's 31. Yep, dark red. Oh, okay, good enough. Now, I can get the derivative at that point, and if I have the derivative, I might as well draw a line, right? The tangent, so we can see what that derivative is going to. No, I have to think. How can I turn that into something I can draw as a line? I'm afraid I need an angle. So a line through a point in a direction. So the point is clear, and the direction still needs to be calculated then. So have to pass a layer. So the create line takes a layer, and then the line style. And then a point, and then the direction. No, I need to create that one. So that would be another line style. Line width, definitely. These here I can specify just the color. No, a turquoise or something like that. I think that's a yeah. I can even see how it looks like. It's way better than the index thing. Now I still have to make my direction. That thing has the following. Can create a direction from a line. Yeah. Oh, sorry, I'm trying to create a line. Point that goes in a line through the origin and a point. Direction of a line piece, direction of a line. Direction given 2 points. Direction given a theta in radians. And I'm afraid this is the one that we need. But then again, I don't have an angle. I could create 2 artificial points. Yeah, I think I'm gonna create 2 artificial points. From 2. So the second point must be that point plus something that resembles the derivative, which is, I think, a vector. I can add a vector to this. So you have a vector, vector from 2 doubles. That should work, right? Oops, warning, ignoring. That's not good. We have to do the derivative. At least I think it was an auto reference. No, I'm not sure anymore. No, just auto. Of course, just auto. What am I thinking? In order to keep the thing alive, so it must have a destructor. So it is definitely not a reference. ISO C++ requires field designators to be specified in declaration order. Snore. I think they made a mistake there. Yep. Or not. It's all warning here. Oh no, that was the previous one. Yeah, now it worked. And that looks like a tangent line, so I guess we succeeded here. Yeah. Yep. Yeah, so the learning rate, the initial learning rates are super arbitrary. I think it just should be really small value. Yeah, no. Don't like the arbitrariness of it. Okay, so we have a loop here, and then the road is drawn, everything's done. We even draw it maybe. And then I don't want to block, I just want to keep on drawing high speed. Or maybe just wait for the key. So which key shall, now currently all my keys terminate the application. So you can add a special key that does not terminate the application, but does return from handle input events. Space maybe? I think I'm gonna go for space. Looks so weird, this, because in terms of unity, it looks weird. The learning rate is initially, you know, the unit less, you would think. And then this is dl dw, so it's the unit of L divided by the unit of W. So whatever that is, it's not equal to the unit of W. Unless the learning rate is equal to the unit of W squared divided by the unit of L. But that's also not the case, because in the end, we set the learning rate equal to this. So there is an, well, it looks like the unit of W divided by the unit of, oh, wait a minute, this is, oh, wait a minute, this is L divided by the W, yeah, so it is W squared divided by L. Yep, the thing has a unit. Let's add that here as well. A really weird thing. But again, anyway, then this makes sense, because yeah. Let me fix this handle input events thing to wait for space. Yeah, it's not gonna work. Let's just write everything and then grab, well, 107. This is done in the Windows. It's 3 times even. What the hell? Don't need to push anything. Okay, so if, oh god, I don't know what the space is. We only have a key code here. Yeah, I really have to fix it, and really I should fix it. It's not easy to convert key codes. Well, okay, let's gamble that it is 42. Assert event key code equals 42, otherwise something is wrong, right? Ah, it wasn't 42. I have two space bars though. So is one different from the other? What do you think? I don't know which I pressed. 65. Let's try this again. Run. I pressed the right one. I think I did that before as well. The right one is 65. Yeah, I must probably, I don't know, quit. Run, that's the left space key. Oops. Also 65, so that's actually the same key in every way. Oh, wait a minute. I don't think it does anything now. It's not returning. Press space whatever I want, but it is not working. We have to send it. So really, I should do so now it sends a message, which is then received somewhere else. So I can grab for the 107 again. What's this? It's key release. Guess we want to see that as well. And I guess it's received here. The key press. Else if message detail key code is 65, just return true. Yeah, did you see it move? It went a little bit down. So I press it again and again, and I just repeat space. So it's basically it's never going to get in the minimum because it's going slower and slower and slower. Classic case of Aristoteles and the turtle, aka trying to reach the speed of light. No. Yeah. We can begin with increasing it immediately a little bit, because it was a very little amount. I want to see this. Oh, what the? Oh, I pressed an M. Never mind. Well, 10 times as big as the last time. So now it kind of looks like it reached it. Not too bad. So that seems to work, as it were. And then next, of course, is that we're going to implement our sneaky trick of changing the learning rate as soon as we have 2 points. I don't really have to store the point, of course. I just want to store the previous W value. Nah, bullshit. Use W. Let's make a counter in 0 points. At this point we did draw 1 point, so now we have 1 point. And then if n is larger than 1, we do our trick. Here we set the previous W equal to W before we change it. So if n is larger than 1, previous W has been set. And we're going to adjust just tiny acceleration. Not much, but I think W minus previous W divided by the derivative, right? The derivative values. The other way around. Previous W. Now, what do you think? I press the space and it goes there. And I press the space again and it goes there. Oh, that was fast. And now we are there. Press space all you want. You get even not a number, because it is 100% 0. Yeah, it's so close to 0, I guess, that we can't even draw on. No. No, okay. I don't know. What happens there? DDB. Run. It would never crash, of course. Space, space, space. Oh, no crash. And again space. A few spaces and we crash. Because the direction cannot be calculated. Why would the direction not be? Can the direction not be calculated? That does not make any sense. Of course, plot P is still. Oh, the x and y values are not a number already. Or the plot itself could not be calculated. Which of course means that w is not a number. Yep. And why did that happen then? Because Leningrad is not a number. Absolutely. And that's because these two are equal. Yeah, and that's because W and previous W are the same value. Duh. So we get here 0 divided by 0. I guess if W doesn't change, or doesn't change enough, then you should just terminate. Or, I don't know, not go to the top anymore. That's line 147. So if we press the space and we go here, but the previous W is equal to the current W, or at least close enough. If utils almost equal, I have no idea how that works. Then break. Almost equal, how did that work? Okay, just two values and an absolute relative error. So the previous W and the current W are, well, almost the same. Absolute relative error. Well, what exactly that 1/1,000,000th meant is it's not where I wanted to go. Yeah. So the difference is a millionth of the average value, but they are the same. So that is a million. The difference is a millionth of the value itself. But this is the complex version. The complex. Let's forget complex here. Well, it's the same thing. Well, yeah. Yeah. This is good. Millions is of course. Then we have six digits precision. Reach the answer with 6-digit precision. That's like way enough. And I bet we get there in like immediately, because it's very fast, this one. Almost equal, blah, blah, blah. How other people can write programs without my utils is beyond me. I don't understand how they do that. Okay, space, space, and now we are there. I hope, with, like in one step, with a precision of 6 digits. So space, yep, oh, or not. What happened? We don't exit. Kind of exited because there's no cross anymore. Oh, it did it. Okay, we return, indeed, it did return, but it did not exit because the program is still running. I'll have to click here, I guess, or some other key. Yeah, okay, good enough. And now, I should have gone to bed half an hour ago, but I'm really starting to be super curious now. What happens if we make this formula a something that is not exactly a parabola? For example, w to the power 2 c times w plus d. I just make it a third degree polynomial, I guess. So I need a d here. And then we need a d here. No. So just a tiny little, yeah, tiny, well, something tiny, so initially tiny. Whoa, no minimum. It was not tiny enough. Really? That's fast. Yeah, I still want to have the same minimum, just, you know, really tiny deviation from actually having a parabola. Let's make this thing even smaller. It's still going to be a local minimum, of course, because in the end it's going to minus infinity, so you don't even have a minimum. But hey, this looks like a minimum, yeah? So if you go further to the right, it's going to be down, 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 and then all the way to minus infinity. But this first part kind of looks like a parabola now, but it isn't. So what happens? Space. Now the second space previously went to the minimum bang, and now it doesn't. Well, pretty fast, I would say. And then the next space is going to do what? But still not. You can still see that the line is not horizontal. Whoa, that's slow. But now it's horizontal. How many spaces was that? Come on, let me start over. Baha. On the count until we reach 6 digits accuracy. Before it was like 1, 2, and then we were already there. So the third one was exit. 1, 2, 3, 4, 5, 6. Wow! In 5 steps, 6 digits accuracy. That's pretty good, man. Very good, very good. Now I'm going to bed because it's getting way too later than I wanted. Again. Okay, people, thanks for hanging out. I wish you a good night or morning or wherever you are in the world.